Hello, are you ready to get cubed? And that covers the first problem with squares. What if I took that same circular base, x squared plus y squared equals 25, and I filled it with cross-sectional pieces that are equilateral triangles? Well, basically I'm going to have the same thing. I just need the volume from -5 to 5 of a of x dx. So the only challenge here is to find a of x. And we know it's an equilateral triangle. Sorry about that. Equilateral triangle. So let's calculate the area of an equilateral triangle. And you know lots of things about equilateral triangles. You know, for instance, that they all have 60-degree angles inside. And that's going to help us a ton when we have to find the height of our equilateral triangle. Because hopefully you remember that distance across the bottom is x, then the height is x root 3. So if I can just find half this distance across the bottom, I'm going to be in good shape. Well, I'm going to refer us back up to our first problem because the distance across the circle has not changed. It's still 2 times the square root of 25 minus x squared. That chord still has that same distance across since we didn't alter our circle. So 2 minus 25 minus x squared is the total distance across the bottom of our equilateral triangle. Well, then that means that x is half of that, so 25 minus x squared, and I've got to throw a square root over this, would be the distance of x. That's going to make the height then the square root of 3 times the base, or half the base, 25 minus x squared. Now we've got the height and we know the base. And we can calculate out the area of the triangle, or the a of x that we're interested in, simply by going back to the basic geometric formula for a triangle, 1/2 base times height. So we have 1/2 times the base, which was 2 times the square root of 25 minus x squared, multiplied by the height, which is the square root of 3 times the square root of 25 minus x squared. Simplifying, we will get these 2's to cancel. 2 over 2 going to 1. Square root of 25 times square root of 25 will simplify as well. So I'm going to end up with the square root of 3 times square root gives me 25, the argument inside the square root, 25 minus x squared. A of x, boom. Easy. Now to get volume. Volume is going to equal the integral from -5 to 5 of a of x, which is square root 3, might as well put that out front, and 25 minus x squared dx. And if you do that by hand or by calculator, it should come out to 288.675. Cool. One more problem I'm going to have us do, if I can advance this screen. Here's the last problem we're going to walk through. Find the volume of a solid whose base is not a circle this time, whose base is the region bounded by the functions. Okay, so we're going to have a line function as well as a parabola. And then we're going to make the cross sections isosceles right triangles, and let's keep these perpendicular to the x-axis. So kind of similar to what we just did, only our region is going to be slightly different. So let's graph this out. Well, let's see, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2. I know this one. Dropped by 1 and it's parabola, so it's going to hit there. up 1 over 1, up 1 over 1 for the starting. We don't have to be tremendously accurate. Let's just get the general shape going. So we've got a parabola. Next, let the line come in. So starts at an intercept of 2, down 2 over 1. Oh, there's an intersection point. Up 2 over 1, up 2 over 1. And we should be intersecting somewhere up in here. So the region that we are interested in, filling with cross-sectional isosceles right triangles, that's not quite what I wanted, is this region right in here. So that's what we're interested in. Where is the intersection on this? Well, we could quickly solve for that. Let's get off that. 2 minus 2x will equal x squared minus 1. And bring everything to one side. I would have 0 is equal to x squared plus 2x. And a minus 3, it looks like. And that will factor quite nicely into x plus 3 and x minus 3. Oh, I'm sorry, x minus 1. Giving us values at x equals -3, and also it'll intersect at 1. So no big surprise here. There's the 1 where x is crossing. We're intersecting the two segments, and then x equals -3, which isn't quite drawn to scale in mine, but that's okay. Okay, so what we're going to do is fill this thing with cross-sectional pieces that are perpendicular to our x-axis. So we're going to lie in some isosceles right triangles, which means that I need the area of the isosceles right triangle. It'll travel from -1 then to out to -3 on the x-axis. So when I get my volume, here's what I'm looking to do. I want the integral from -3 to 1 of a of x dx. All I really need, the challenge is going to be to get the isosceles right triangle area. And we know in an isosceles right triangle that the two legs are equal. So what we want is a of x here. I'm going to take that out of there because it'll just get in my way when I do height. So let's trace a height line in here. We need the height of this isosceles right triangle. We also need the base. We know in an isosceles right triangle that the legs are the same, thus making the base angles the same, which would force them into 45/45s, and I'd have my right angle up there. That also then generates another new 45/45 because the height will bisect the vertex angle of 90 degrees, making it 45/45. So what you remember hopefully from geometry and special rights is that you have x, x, x root 2, but we won't need that outside. So if we can find x, half the distance of the base, we're going to be in great shape. Well, that distance of the base is what is lying on the base region, which is the distance between these two curves. And the distance between the two curves can be generated by going top minus bottom. So the top curve is going to be 2 minus 2x. Subtract the parabola, which is on the bottom, x squared minus 1. That's a 1. And it's a negative. That is the length of the base. And that would simplify down to negative x squared minus 2x plus 3. Awesome. We now know our base area. Our base is that, which means that our height is also this, because they're equivalent. And then I just have to go into formula for, oh, hold it, the height is equal to half of that because I only need half this distance to get height, don't I? So half the base, sorry about that, glad I caught that. Negative x squared minus 2x plus 3. All right, so let's get the area of our isosceles. Area equals 1/2 base times height, which will look like 1/2 from the formula. The base area, negative x squared minus 2x plus 3. Close. Times the height, which has another 1/2 factor, times negative x squared minus 2x plus 3. There's our area. So all I have to do for volume now is go volume is equal to the integral passing from -3 to 1 on our x-axis of this function up above, which has 1/4, put the 1/4 out front. Let's see, let's just take that negative x squared minus 2x plus 3, square it, and dx multiplied by the width of each of these, and we have our volume, which is coming in at 8.533. Boom, done. That is excellent. We can call it quits. I hope you kind of get the gist of what we're after.